So this is the second video about logic gates. To be honest, I'm probably going to split this into a couple of videos, simply because there's too much to get through in one. I think it'd be good to split, because I'm going to talk about two different things, really, two different applications of logic is what I'm trying to say. We left the last video with these beautiful things. We've got the symbols, the sort of circuit diagram symbols for an AND gate, an OR gate, and a NOT gate, and the Boolean algebra symbols for them if you stick them in expressions. So this is the conjunction operator, which is like an A without the cross bit. The disjunction operator, which is like which is a V, which isn't that. And then this little negation operator, which is like a gun, a pistol facing left, top left-hand side of your keyboard, just under the escape key. Then we looked at the actual behaviour, logical behaviour of these systems, and remember these tables are just massive abstractions of real situations. So I've used 0 here and 1 here, whereas the 0 could represent, well, it could be a 0 I suppose, but an off, so switch being off, a false, 0 volts, 0 height, anything that's like 0 based, and the 1 could be something that's the opposite to that. So on, for instance, true, plus 5 volts, up, whatever. High. So remember that because I've abstracted the behaviour to this, I can apply these to loads and loads of different situations, all right? As long as I keep in mind as what the zeros and the ones could be. Anyway, I'm waffling a bit. But I'm not, because it's all relevant, isn't it? So let me show you the behaviour of programmed behaviour of logical operations. So I'm going to focus on the 3 logic operations one at a time. So I'm going to first of all look at an AND operation. An AND operation. So I'm going to come up with a programmed scenario and then show you where an AND operation would sit and why we'd use it and how it would evaluate and so on. So if I go for, this looks like Python, and I'm going to pretend it is Python, right? Height is 1.9. Now that's a nonsense. Right? These two statements are a bit of a nonsense here, because in practice, of course, I'd never do this, because I'd use an input statement to get the value of the height and the age of the person. This looks suspiciously like a roller coaster decider, which you've probably done in class. This is pointless, because everybody in the world's 1.9 meters tall and age 13, according to my program. But nevertheless, I'm just saying. So here's my selection statement now. So I'm going to use these two facts to make a decision. If, and I'm going to write it out, and then I'll talk to you about the different bits. If height, and I'm talking this, greater than or equal to 1.4, right, fair enough. Come back to that in a sec. And there's me Boolean operation, and age is greater than or equal to 16, right? Now, hopefully, I think this is a scary roller coaster ride, and you have to be 16 years old and 1.4 meters high. It's a little kiosk at the entrance, and you punch your age in and you punch your height in, or it measures your height for you. And if you conform to the rules, then it prints clear to ride, or it opens the gate or whatever it does. I don't know, something like that. All right. So again, I'm abstracting all the time. We're always abstracting, computer scientists. Now, this AND operation here can't do anything until these two statements have been evaluated. These are statements, decision statements, assertions, if you will, that I believe on my heart of hearts to be true. So I truly believe that height is greater than or equal to 1.4. The programming environment, Python in this case, says, yep, you're absolutely spot on, it is, so it returns true. Your statement is true, correct. I can abstract true to a 1. Nice. Let's have a look at this, right? I truly believe on my heart of hearts that age is greater than or equal to 16. Python, tell me I'm true, tell me I'm wrong. And Python says, no, you're wrong, it's not. So your age is 13, so you're wrong. So that evaluates to false, which abstracts to 0, right? And in between those two, I've got my operation AND. That sits in between those two. At that point now, the AND operation can evaluate the operands, because they've got values, right? But let's have a look. So 1 and 0 is what I'm looking for in my table. 1 and 0 is 0. So in other words, when this evaluates, it evaluates to false. False, which abstracts to 0, or the opposite to that, de-abstracts, unabstracts, less abstracts, I don't know. So in other words, the decision statement is false, and that doesn't print clear. So in this particular scenario, that won't print. I mean, that makes logical sense, doesn't it? So let's look at second bunch of second thing in the bag is a not operation. So we'll go with not. No, it's not. No, it's not. It's not. It's or. I'm getting ahead of myself. So it's or this time. So let's have a look at how an or might operate. Now, I'm the laziest person in the world, and near my front door, I've got a kiosk, and that kiosk, right, is attached to some weather sensors. It might even be getting live data from the Met Office. Not that I could just look out of my front door and see what the weather's doing. You know, I've got to do it a different way, bleeping things. So my sensors are saying it's not raining. Sorry, it's not snowing. No, it is snowing, but it isn't raining. Right, I could just look out the front door, but you know, techie and all that. Now then, it's an umbrella decider this. If, right, snow, if snow or rain, oops, didn't tick the box, or rain, different colour. Woo! If snow or rain, right, colon, print, umbrella, right, not that I can make that decision myself, clearly, I'm not capable of doing that, I have to get a computer to do it for me. Now, again, the or operator can't evaluate its operands because they doesn't know what they are, because they're just variable names at the moment. So what the Python will do, whatever you're programming in, we'll look at what snow's value is and see that it's true and evaluate that to true. Because you notice I didn't put I didn't need to put an equality operator there. I could have done, but it's actually a little bit more work than I need, because if I'd have put, so I'm going a little bit aside here. So if I'd have put, for instance, if snow is the same as true, right? Okay, I could have done this. I could have done that. If snow is true, right? But that would snow is true, right? So that is true. So true equals true would evaluate to true. Well, that seems a bit pointless, doesn't it? Simply because snow's already true. So why do I need to go to do more work to get the outcome true when it's already true? Because it's Boolean to start with. So in that sense, that's why sometimes you see this in programming. If snow, right? Because it's Boolean, and then you don't need a comparison operator in it. Nevertheless, rain evaluates to false, right? True abstracts to 1, false abstracts to 0. So now my OR operator has got its operands. Hurrah! It says, and it has a go at evaluating what it looks like. Now, basically, I've got 1 or 0. Let's look back up at my truth tables here. 1 or 0, it's the same row. It evaluates to 1. That kind of makes sense. So we've got basically that evaluates to true, which abstracts to 1, and therefore my umbrella decider prints umbrella, and I pick my umbrella up and I go out. Not that I could have done that without writing a computer program to do it, but you get the idea. Now, last one in this little vidoir is the not operator. I tried to sneak this one in a bit earlier on. I'm going to be consistent and make my characters slightly wider. So the not operator. Now, you've seen me using the not operator before, if you've watched any of the programming videos, when I've been doing conditional looping. This is very, very common methodology of doing it. So I'm going to set a Boolean variable finished equal and make that equal to false, right? Before I start my loop, while not, right, my not operator's here. Remember that the not operator is a unary operator, so it only takes one operand, while not finished. And I use the word finished because I think it makes grammatical sense in the statement to do that. Do some stuff, right? Now let's evaluate that and have a look what's happening. Of course, the not operator can't evaluate this because it doesn't know what it is. So the first thing that happens is that Python, for instance, will say what value does finished have, and it has the value false. Right, now false abstracts to 0. Now the not operator can do its job, so not can do its job, not false. Right, so that's not 0. So let's have a look at what not 0 looks like. Not 0 is this line here, which evaluates to 1. Right, okay, so in other words, not false evaluates to true, which is 1. And the loop continues. Now, at some point in that loop, there will be a statement, and if this statement doesn't appear, the loop will never finish. There's got to be a statement somewhere that says finished equals true. At that point, if you think about it, not finished will evaluate to not true, and not true will evaluate to false, and the loop will then exit. Okay. So there's applications. I mean, you can actually chain these together. You can chain these together as well, so you can have ands and ors and nots and so on and so forth. But you've got to be quite careful that you force Python to perform these in the right order, because actually, as we'll see in the next video, which I'm not going to show you now, but we'll see in the next video on logic gates, which is about sort of more practical applications of logic gates, they have a precedence, just like mathematical operators do as well. So I always would tend to put brackets around things if I was trying to force Boolean operations to be executed first. I'd always tend to use brackets. So use copious brackets to make things sure that you know that things are going to happen in the right sense. But that's how you'd use Boolean operators in programming.